Hey guys, Jay Wilson here. I had a super great time in class tonight. I'm sure you guys all did too. In case you didn't know, I am a little bit of a SQL junkie. I do develop data warehouses for a living. And after the class, I was super excited to kind of go over these tutorial questions. Where are they? These guys. And I was reading through them, looking at them, and I just started working on them. And I realized I don't necessarily know that, unless you have a background in SQL, you might not be prepared to tackle these questions. So I thought I would take the time to go over a little bit of like introduction to SQL, work through a couple of these exercises to kind of give you an insight into my workflow, and hopefully set you up so you're in a better place to kind of move forward with developing these really kind of basic, but also would be easily used as an interview question type SQL queries. In any event, you'll notice that I'm not using the Oracle environment. I am using Microsoft TSQL. I took the time to take the TSQL or the Oracle SQL statements and convert them into TSQL and load them on my database on my computer because I just didn't want to do it in Oracle. It was super slow. So it's on my computer. The code that I generate is just about the same. There are some minor differences, like Tassos mentioned. Oracle is not case sensitive. Microsoft is usually not case sensitive. It's not case sensitive in strings unless you have a certain setting. Short version of the story is my code probably will work in Oracle. And if it's a case that you might have to like do some short Googling to see how the syntax differs, but it should be mostly the same. All right, let's get started. Before we even start worrying about writing a SQL statement, you probably should know the pieces of a select statement. So piece number one, and arguably the most important piece to understand, is you have to have the select. The select says, what do you want to see? Now, side note, you don't have to have a from argument. I could just say select one, and you'll see down here in my results column, I'm pressing F5 or execute, same thing. You'll see down in my results column, I've returned the value 1. In class, Tassos mentioned this idea of an alias. And you do want to learn these vocabulary words because when you know vocabulary words, you can Google things later. But alias is basically to just give something a name. And you can alias tables, like he was talking about aliasing the employee table and a manager instance of the table. But you can also alias columns, which he did at the end when he took the alias of the, was it sum of count or sum of salary or something? But anyway, what I can do here is here in my select statement, I can write select one and I can alias it as a number. So now when I run my select statement again, here, you'll see the column is no longer blank. It is called a number. This is going to be super important as you start working through these exercises. You have to understand aliases in order to be successful, just full stop. So take the time to Google aliases if it doesn't make sense yet. All right, so what was I saying? The first part of a select statement is in fact the keyword select. It does not have to be caps, but it's, nice for visualization. I'm going to do select star, and I'm actually going to pull data from a table. In this instance, I'm going to pull data from the EMP table. If you didn't know, select star means pull every column. So if I execute this code, it will literally pull every column. Now, best practices says do not pull every column. Do not go to your production database and do a select star from a table, because if you can imagine a table with 60 columns and millions of rows, your DBA will be really upset if you do a select star on a really large table. So even though it's fine in these examples that we do here, just as a side note, probably shouldn't just do select star. You can and should select the fields that you want. So in this case, I'm going to get started on the first example here, which is select the details of an employee whose manager, emp number value is less than their own. So I could say, I want to return the employee number, I want to return the e-name, I want to return the job, I want to return the manager. That's one way of doing it. Or I can say I want to select star, and obviously that will return all columns. You'll notice here I use this hyphen. This is how you comment out code in SQL, the double hyphen. In Oracle, it very possibly is something else, and I'm almost positive that it is. But one of the reasons why I structure code this way, where I do select, and then on a new row, I start putting in the fields, and then on a new row, I do my from, and then my emp, is in a world where I'm just doing my data exploration, I can say, oh, select star, and then I see everything. As I start building my real query, I can really quickly switch back and say, nope, just kidding. This is the data that I actually want to see in my final query. So putting things on new lines is a really nice way of making your code both legible and flexible. All right, what are we supposed to do? We're supposed to select details from employees whose manager emp number value is less than their own. So this whose should already clue you in that you're looking at a where clause. And that's the third fundamental piece of a SQL query, is the where clause. And in the where clause, you define your filter criteria. In this case, we want to filter where the emp number is whose manager's emp is less than. So the manager's value is greater than or less than. I'm just going to, because I can't be bothered to think about it thoroughly, I'm just going to say where the employee number is less than the manager employee number. And if I'm thinking about it the wrong way and it needs to be, the sign needs to be flipped, fine, whatever. But the point is, in your where clause, you can do inequality. Do Google the proper spellings for inequality. Usually there's equals, does not equal. There's a couple others that we're going to have to know in order to be successful in these labs. So you're going to have to know in for your inequalities. So do Google it. Note it's not the same as R. R does the double equal sign for inequality, but that's just a syntax change that you get to enjoy. In any event, here's our query. And if I just execute, you'll notice 7902 is in fact greater than 7369. 7499 is in fact less than 7698. So hopefully I did it right. Cool beans. Let's move on to the next one. The next one asks the details. By the way, I'm not doing these in any order. I just kind of picked what I thought was the easiest ones first. Okay, display the details of employees whose managed, nope, I just did that one, Jay. Sorry, delete. All right, display in descending order of grade and ascending order of name, the name, salaries, and salary grades of all employees. Okay, this kind of jumped straight up to 11 real fast, but let's get through it. So what two tables do we need to combine? We need to combine the employee table, and the grade is going to be found in a table called salgrade. I highly recommend, if you don't know what's contained in a table, super easy, select star from salgrade. Now, if you were listening earlier, you remember Jay Wilson said you should not do a select star on a large table, so you can do a select top 10. I think that's going to execute. So in this case, it just so happens my table only has 5 rows in it, but by doing a top 10 or a top 50, I can limit the results that I return and not, run a stupid long query for no reason. This is kind of similar to the head function in R. Go figure. There's a lot of overlap. Again, if I want to be nice, I'll comment it out, but I can just leave it as this. All right, now this is where it gets exciting. In the grade table, you have a low salary and a high salary. And if we're going to relate this somehow to our employee table, I know in the employee table I do in fact have a salary. And now the million-dollar question is, how do I relate these two tables? If you're thinking back to the exercise we did earlier in class where we did a join on a table, what we did earlier in class, let me put a select star in. So I say select star from EMP. Now I'm going to do a join. Join is another way of saying combine, right? Combine the two tables, employee and salary grade. If you start doing joins, one of the best things you can do for making your code more legible is start using aliases right away. So earlier I said aliases are when you give something a name. I said you can alias a column. I think I did the example of select, what did I do? Select one as some name or something like that, right? When you add the as argument, that's how you know you're doing an alias. And it looks like this. Depending on who the programmer is that's writing the code, they might write their aliases as select star from employee table and call it E, or they might not put in the as argument and just say sal grades SG. Either option works when you have a join clause. Let's get to that. So in order to combine the employee table to the salary grade table, I have to do a join on a specific field. So in this case, I have to join on the salary. By the way, this is why I use aliasing, is because it gives me this the tooltips, the context. I can say e.sal is, now it's not equal to sg.highSalary, and it's not, right? It's obviously the e.salary is less than or equal to the high salary. And what also must be true is esal must be greater than or equal to sg.lowsal. Okay, so in previous queries like we did in class, we did a join to another table, but we just had an equijoin where we just said one field is equal to another field. It is possible to do a non-equijoin where you do less than or equal to. Let me write that out in case you can't understand. Sorry. So this is what's called a non-equijoin, right? The values are not equal. Notice that I do have an and clause, right? This has to be true and that has to be true in my equijoin. So now when I run this query, I get a list of employee numbers, and I can also see these are the columns from that other table which have been added. If in my query I'm only supposed to show grade, name, and salary, I would say, okay, I want to show the name, grade rather. Grade is from the table SG, so I'll do SG.grade. And I also want to show E.name. And I also want to show E.salary. Okay, notice I am putting in the alias to identify the table that the field is coming from. This is important in a world where both tables have the same field. So for example, when you join on department number is both an employee and in the department table. So you have to say, what table are you taking the data from? And you do that by showing the alias. This is just, as soon as you start using aliases, all of your fields should show the alias. All right, let's run this query now. Now, instead of doing star like I have here, this time I've limited myself to just these 3 columns. The last piece that we're asked to add is we're supposed to show in descending order. It's called a sort. So we're going to do sort on by. I don't think I need anything else. I can just say sort on grade descending. Ooh, it doesn't like that. What doesn't it like? Sort by? No. Shit, I forgot how to do a sort. I do this all day. How do you write a sort, Jay? here. How have I forgotten how to do a sort? Order by, that's what it's actually called. Sorry, guys. The clause is called order by. Grade descending, then sort by name ascending. That's E name ascending. Now I already broke my rules. I should say what table the data comes from. sg.grade and e.name. Okay, so now I can run this query again, and 54321 king salary. Okay. So the order of the select from order by, these are important. Every query must, I think that's true, every query must have a select. Most queries will then follow with a from. A lot of queries will include the where, which is your filter, and then your order by. Now I remember, right? You'll order by to say what you want to sort your fields by. One of the key things to understand, one of the key things that's going to make you successful in SQL is knowing the order in which these are evaluated. In a world where you have a inner join, so let's say we're doing select from employee, and we're doing an inner join, or just I'll just call it a join because I haven't really talked about the difference yet. And we're joining to the depth number, the depth table on e dot depth is equal to d dot depth. Okay. All right. In terms of the order that SQL executes your query, the first thing it will execute is it's going to work from the inside out. It's going to say, okay, what is all of my data? What is in the employee table? How do I join it to the department table? And it's going to make a massive table of all of these columns. From there, it will move on to parse the where clause. So if you had a where clause where you said, oh, I only want to include rows where the location, which is in the department table, is equal to Chicago, okay. Been writing R for so long now that I can't write SQL anymore. Again, in the order of operations, it'll say take your data from, do the join, identify the where. Okay. Once that's done, it'll say, okay, now what columns did you want to pull? So if you have, I want to show the employee number, right? Then it would start paring down the data selected. You say, oh, you asked for employee number. Cool. The last thing it will do is the cosmetics. So the last thing it would do is your order by clause where you said, oh, I want to sort by salary or something. So this is executed dead last. Okay. Now in a world where you have a group by clause, which we haven't talked about yet, but Tassos kind of did it right at the end of the presentation. He said, oh, well, what if you wanted to know for any department, I want to know the total salaries in that department. So he took the sum of the salary column. All right, let's do that. Okay. What if we wrote this query? Let's see what we can execute. If I tried executing this right now, I would get an error. I'm going to ignore the order by clause for a moment. But if I try to run this query right now, it's going to give me an error. And the error says the department number is invalid in the select list because it's not contained in an aggregate function or the group by clause. In our heads, we know I would like to see total salary grouped by department number, but we haven't written that into our query. We actually have to say BT dubs, I would like to do a group by d.department number. And now I can run this query and I can get a result. Okay, now again, keep in mind the whole reason why I'm on this tangent is because I'm talking about the order that these clauses are executed in. So the first thing SQL does is it says, okay, create my table, my master table. So it says unaggregated, give me my employees and department table and join it as one table. Then apply the where clause. So I go from 50,000 rows spread across all locations just to the 60 rows that are in Chicago. Then it does the group by clause. It says, oh, now I'm going to take those 60 rows and group them by the department number. Then I do my sum and, how do I select the data? How do you want it to look like? Do you have any other, what columns are you going to extract? And then lastly, it does the order by clause. And then it looks something like this when you include the S. I have a new error. The new error says is that the column emp.sal is invalid in the order by clause because it's not contained in an aggregate function or the group by clause. You can't order by eSalary. Let me say that again. You cannot order by eSalary. And you're like, but Jay, I have it up here. Well, you do and you don't. Remember, at this point, we've extracted our data, we filtered it, and then we grouped it. We're no longer seeing individual salary. We're not seeing individual people's salaries. We're seeing the sum of salary. So in order to do a sort by total salary, I actually have to tell it, oh, BT dubs, I want you to order by total salary. And now this will execute. There's one last clause that we haven't discussed. So we're looking at this data, and you might say, but Jay, you know what I really would like to know? I want to just see, let's assume for the sake of conversation I had more departments. Let me take out my where clause. Okay. Okay, we ran this query, and you said, Jay, I only want to see the big departments. I only want to see the departments that have a total salary greater than 10,000. I can't read large numbers. Yeah, I only want to see where the total salary is greater than 10,000. You cannot go in here and you cannot say where the sum of e.sal is greater than 10,000. This won't work. And if you understood what I said previously, the reason why this doesn't work should make sense. Because what is the order of operations? You select your data, then you apply the where clause. The reason why you cannot do a sum by eSalary at this point is because you haven't told it to group yet. So this won't work. You have to ask for the I want to filter by total at the right time. I can say filter where location is Chicago because that doesn't require grouping. But let's keep that part out for now. Let's run our query just to prove that I'm not full of crap. All right, so this query works. I only want to see the rows where this column is greater than 10,000. There's one more I forget what they're called. Thingy. There's one more thingy I can add. I can add a having clause. The having clause will take my grouped data and now allow me to add filters. So I can say, I want to take these 3 rows and I only want to include rows where the total e.sal is greater than 10,000. So I only want to include rows having greater than 10,000. So let's see what that looks like. Boom, I'm down to just the 1 row. I probably should stop the video here, but I've only gotten through like 1 query. But this is really important. You will not be successful in SQL if you don't understand the order in which things are executed. And just one more time, you start with the from, you do your join, you apply the where, then you do a group by. Bam. Once you have the group by, you apply the having clause. The having clause and the select clause, you could say, are applied at the same time. The very last thing that happens is your order by clause. Okay, what does that have to do with the price of rice in China? Where were we? Did we finish this? We did a group by, we did a non-equijoin, life was happy. Okay. All right, I think I'm just gonna do these last two and then we'll call it a day. So this next question asks you to display the departments with employees earning at least as much as Miller. I really strongly encourage you as you're going through these, especially if SQL isn't something you have a lot of practice in, try to break down like the individual questions that you have to answer in order to build the query. So the first question that you have to know the answer to is, how much does Miller make? Right? Then the next question asks you to display the departments that have employees earning at least as much as Miller. The wording is a little bit tricky. Yeah, the wording is a little bit tricky, but ultimately what we want to do is we want to say, okay, which employees earn as much as Miller? Then which departments do they belong to? Wow, if I only could type belong to. Yep, we're just leaving it. So those are the three questions that we have to answer in order to produce this query. So let's do the first one. How much money does Miller make? So again, we'll start with our select statement. The only piece of information that I'm interested in is the salary. So for now, because I can't remember how to spell salary, I'm going to say, well, I know that data is in the employee table. Notice I already did my alias. The column that I want to return is e.sal. Okay, so if I run this query right now, right, obviously I get all the salaries. I don't want all the salaries. I will only want Miller's salary. So I need to add a where clause, and I need to filter where e.name is equal to Miller. I'm not going to go into it right now, but I'm just going to write a question into the chat box, and if you answer it, great, and if you don't answer it, well, you'll suck at SQL. What you need to look up is, what is the difference between like and equals? You need to know, I guess, in the context, let's say when filtering strings, you need to know that answer because they aren't the same, or at least the implications are not the same. In any event, all right, so how much money does Miller make? Can't wait to know. Miller makes $13,000. So then the next question is which employees earn more than Miller? So let's just start by making a new query. I'm just going to do, what are we looking for? From emp e. And what field am I looking for? I'm just going to return e.name and e.sal. Okay. So here are all of the employees. Now, given I know that Miller makes 13,000, I could write my where clause as where e.sal is employees earning as much as Miller, is greater than or equal to 13,000. I could write that query, I could execute, and I would get the right answer, sort of, because there's still the third part. But I would get the right answer up to this point. But that doesn't make me a badass. A badass is somebody who doesn't have to hand code this value in. The badass is the person who can combine these two queries. So one thing you can do is what's called a subselect, which is to have a select embedded in a select. ooh, sounds scary. It's really not. I'm just going to wrap this whole thing in quotes. So first thing I'm going to do is indent, because I like my indents. And then I'm going to wrap this in an open parens. And then I'm going to put the close parens down here. So basically what this says, well, let me just prove to you that it gets the right answer. All right, it still gets me the answer, and everybody makes more than, don't make a liar out of me, I thought, how much are they supposed to make? Yeah, everybody makes more than 13,000. Okay, and basically all this does is it says, hey, instead of having the hard-coded 13,000 up here, I'm saying run this query and give me a result. Now this only works if your select statement returns one value. So let's see what happens if I had multiple people. Here, I'm going to show you oh yeah, I'm going to give you the answer. So shit, is it percent or star? Gosh darn it. M star, if only I remember how to write SQL. I've been writing R for so long. Okay, M star usually means wildcard. That's a lie, it's percent. M% usually means wildcard, I think. But if I run my query, I get no results. And the reason why I get no results is because I have an equal sign. If I do like, then I get results. So I just answered this question. Rewind the video and watch it again. So the problem though is now this query is returning 2 rows. Let's see if that has any effect on my select statement. It does. I get an error. It says the subquery returned more than one value. This select statement returned more than one value, and it's not permitted. So the easy answer is obviously to just say, okay, let's put Miller back in. Because I know if I run Miller, I will only get one result, and the query works again. But if you're in any way interested in doing this as a job, you have to be able to build robust code. A better solution might be, and I'm just making this up right now, I don't actually know that this is going to work. A better solution might be to say, well, give me the average, because in a world where I returned multiple Millers, by using average, I get a null. Why did I get a null? Because it's not supposed to be a star j, it's supposed to be a percent for F's sake. Get it together, I know it's late. Okay, by taking the average, I still only get one value. This query runs. It's not the one that we originally asked. It's not, what the question asked for, but this code is more robust by writing average. And even if I just go back to using Miller, this still works, because average of one row is still 1300. And so this is a better solution than just passing eval. Okay, so we're almost there. The last question was, which departments have employees that earn more than Miller? So I guess what we should do is just replace this with department. Piece of cake. Except, oh wait, department number is in this table, but department name is not. So I need to do another where clause, or an inner join. Sorry, I'll just do a join because we didn't talk about what an inner join is. Dept D, join to dept D on E dot dept number is equal to D dot dept number. And now I can return D dot name. We're almost done. So I run this query, and if I look at it, I see sales, research, blah, blah, blah. I see research twice, 3 times. I see accounting 3 times. I don't like that. So what can I do to only get a distinct list of department names? And I just gave you the answer. The answer is select distinct. Take this set of data and make it distinct. And then I just see each value 1 time. I hope you're asking yourself, but Jay, how does distinct play into this long speech you gave us about each of these arguments and the order in which they're executed? Well, it did exactly what I said it would do. We did the from, and then we did the join to the department table. Then we did our filter on the where clause. Our where clause happened to have a subquery in it, but it still filters. Then the last thing it does is it says, what should the presentation look like? Select your columns and apply a distinct to it. So I didn't lie. It still did the right thing. Home stretch, Jay. I got this. I got this, guys. This is the last time I do a tutorial at 11:51 p.m. All right. Display the details of employees who are not clerks, but who work at the same location as the employees of the sales department. This question is just unnecessarily complicated. But let's break it down into its component pieces. Okay, so the first question we need to ask, or answer rather, is in which location are employees of the sales department? So that's the first question we need to answer. So location is city. So like, what city are my sales team in? Chicago, New York, Wisconsin. Okay, fine. Once you know the answer to that, then you want to know which non-clerk employees work at those locations. Okay. I'm half tempted to do this the wrong way and talk about why it's wrong before I show you the right answer, just because I feel like I should do it. All right, so let's assume that you kind of set out and you did it half right. So you did select the information that I want. Let's do from, let's do star, select star from emp E. We already know, oh man, I'm on a roll. I'm going to do a join to the depth table D. I'm going to join on E.depth number is equal to D.depth number. Okay, so I've got my foundation in place. And then you say, okay, well, in my where clause, I only want employees who are not clerks. So I'll say where E.job does not equal clerk. Now let me just run my query to make sure I get results. That looks good. I can see all of the people who are not clerks. And then the query says, I want to have only, I only want people who are in the same location as employees of the sales department. And I saw sales department, I see D name is sales, so then I filter and I say where. So I say and D.D name is equal to sales. And then I think I'm done because I got all my queries, right? I filtered where the location is sales, so they're in that location, and I filtered where they're not clerks, so I should have everyone who's not a clerk, and then I run my query, and it looks right, but it's wrong. Well, I mean, given that this data set is only 14 rows, it's possible that it's correct, but let's just take a quick look at some summary statistics. Okay, there's 5 rows returned, and I think this is the wrong way to do it, so let's talk about the right way to do it. Let's start by making a list of locations that employees in the sales department are in. What do I want a list of? Locations where department name is sales. So I'm going to do select star from dept. And what do I want? I want a list of d.location. And which locations do I want? I want a list of locations where d.department name is equal to sales. Let's run that query. So the answer is Chicago. All of my employees in sales work in Chicago. So given that I have the location of employees in the sales department, now the next part is make a list of all employees who work in Chicago. So this is going to be just like we did in the last query. It's going to be select star from employee E where, oops, have to do our join first. Join to dept D on E dot dept is equal to D dot dept. Okay, so this part's good. In my where clause, I'm going to do what we did earlier. So I'm going to say where, let's just start with E.job does not equal clerk. And this is where our queries fundamentally differ. And D.location is equal to Chicago. This time, when I run my query, how many rows do I return? I return 8 rows. Now, what is true about all 8 rows? They're all in Chicago. But notice, I have people from research. There are people in the research division who work in Chicago, and that's why this query returns 8 rows, whereas this query, which is air quotes wrong, only returns 5 rows because I only have the sales team, and more than just the sales team work in Chicago. We're almost done, swear, because I want to be done too. Down here, we have the same syntax that same technique that I used earlier of having a subselect within my query, and it has the same problem. Remember earlier up here, I said, when the E name is Miller, you only get 1 sale, but what if you did M star, so anybody whose name starts with M, then you would have multiple salaries, and that's when our query broke. And I said, we'll use average, and you can get average salary, and even though that's not quite what they asked for, it's more robust. You have the same problem down here. It just so happens that your entire sales team, is based in Chicago. But what if your sales team was in Chicago and New York? Well, you can't do a max, you can't do a min, because those kind of operators only apply to numbers. So in an instance where you're doing a subselect, the correct thing to do is not to say equals, but in. I want to include all records where the location is in this list. So to make sure I'm not full of shit, because I could be, it is late after all, we're going to say where d.name is in, oh God, how do you do a list? Do you do sales or research? I think that's how you write that. So which let's run that. Oh, fine. What are some other department names? Okay, so let's do accounting, because accounting is in New York. So in a world where I want to see all employees that are at locations that have sales or accounting, my location list is New York, or Chicago. So again, I'm returning multiple values. Now I run my query. I'm showing Chicago and New York, and I'm showing all non-clerks. Okay, so again, at the end of the day, you learned hopefully a couple different filtering methods, and I think I wrote them at the top earlier. I said you need to learn about equals. You need to learn about does not equal, obvious, but you also need to understand what in means, and I guess I should add like. Okay. That was your crash course introduction to SQL. I hope it wasn't too long. I hope it wasn't too dry. Again, if I had to pick a list of the things that I think are most important for you to understand, especially if this is day one for you of writing your own SQL from scratch, understanding the order that these execute in is absolutely critical. From there, just get start writing SQL consistently. That was one of my huge failures when I was getting started. My code was all over the place, and it was really hard to read, and it was really hard to maintain. So do this where you have select, indent, from, indent, join, so you can just see everything really easily. If you're using Oracle, figure out how to comment things out. And then lastly, do try to break your queries down into these are the pieces of information that I need to have in order to answer the question. If you don't do this, you'll end up with mess like this, where you get a query that, this guy here, you get a query that runs, but it's not the right answer, and it's not immediately apparent why. In any event, I had a blast doing this. If you guys think it's worthwhile, let me know. I'll be happy to do some of the more challenging queries from the tutorials. I'll do it in TSQL, and I'll leave it to you to translate to Oracle. Anyway, thanks so much, guys. I'll catch you later. Bye.